Yo, what's up, everybody? Hold on, let me close my door real fast. Okay, so this is your test review. I'm going to be going through the answers here. For those of you in Miss Edwards class, what is up? I'm going to be showing you guys how to answer all these questions for our review and getting ready for our test. Hopefully you have this done already. And you can just kind of thumb through this video and take a look at the problems that you missed. Hopefully learn a little bit about it. So let's jump right into it. Problem number one. Jessica completed 6 math problems in 15 minutes. Good job, Jessica. Brian completed 36 math problems in 90 minutes. Okay, makes sense. More problems, more time. Did they work proportionally at the same rate? And what we're asking here is those of you in my class, we use the word equivalent here, but Miss Edwards likes to use the word proportionally, but essentially the same thing. What we have to do is take both of these rates, and we're asking, are these rates equivalent? So what we would do is find the unit rate of each of them and then compare them. And if they have the same unit rate, then they're equivalent. So minutes, problems, minutes, and problems. I'm going to find out how long it takes Jessica to solve a math problem and find out how long it takes Brian to solve a math problem. So I'm going to set these to 1 and 5 by 6. 5 by 6. 2 times 3. Decimal. Yes, this goes in. So 2.5. 2.5 minutes is how long it takes Jessica. Brian will be 6. 90 by 36 goes in 2 times, which is 72. And 72 is 18, which is half of 36. So that is also 2.5. Yes, those are equivalent. Takes them both 2.5 minutes to solve these problems. Those are equivalent rates. Next one, number 2. At a school carnival, the student council made $150 in 30 minutes. At this rate, how long will it take student council to make $600? This is money over time, right? Minutes, money over minutes. That's 150 over 30 minutes. That's the rate that's given to us, right? So we got to find the missing number here, right? Money across the top, minutes across the bottom. So how do we get from 150 to 600? We could find unit rate here, guys, to find out how much money they make per minute and multiply out. But this is a ratio where we could easily multiply 150 up to 600. And 150 goes into 600 4 times. So 150 times 4 goes 600. And if we do the same thing on the bottom, we'll keep these rates equivalent. 30 times 4 would be 120. So it would take them 120 minutes to make $600. The unit rate on this one would, I believe, be 15 divided by 3 is 5. So 5 minutes or $5 a minute. So then you could just multiply that up. 5, however, it goes in 600. Just works the same way. The next one. Select 3 of the following statements represent unit rate. Andrea bought 3 bananas for $1.20. No, that is not unit rate because it doesn't represent 1. At Central, there are 30 kids in a class. That's 30 kids per class. That's 30 kids per class. That is definitely unit rate. Mrs. Philbom drove 150 miles in 3 hours. Nope, that's a rate, not unit rate. We would be looking for miles per hour here, so that is not unit rate. I spent $1 on 5 candy bars. Now, someone might say that this is unit rate because there's a 1 here, but we're talking about price per candy bar in this particular instance. So we're not getting unit rate here. We have 5 candy bars, but we need the candy bars to be at 1. That's not unit rate either. On the freeway, the speed limit is 65 miles per hour. There we go, unit rate, right? We're talking about how many miles in 1 hour. And then Mrs. Edwards put 4 students in each group. Again, unit rate there as well because we are putting the students into 1 group. Number 4, Mrs. Edwards has 24 Sharpies. This is a great question. 6 of the Sharpies dried out and the rest are fine. Okay. Part A. What is the ratio in simplest form of Sharpies that are dried out to Sharpies that are fine? Dried out over fine. And I tell my class, and I'm sure Miss Edwards has told her class, write it out in words first so we make sure we get the correct numbers picked. So I need Sharpies that are dried out. It says here 6 Sharpies are dried out. Boom, right there. Goes right on top. The markers that are fine go on the bottom. So that would be 24, right? That's a big misconception. A lot of kids think it'd be 24 here, but it would actually be, it wouldn't be 24 because 24 is our total number of markers. If 6 of them are dried out, then 24 minus 6 would be 18 of them that are working. So 24 markers total, 6 are dried out, 18 of them work. So that would be, boom, 18 that goes on the bottom. And then we need to simplify this down. The greatest common factor between 6 and 18 is 6. We end up with 1/3. So we need to find which of these shows the ratio of 1 to 3. Both of these ones have a 1 and a 3, but remember it's dried out to fine, so it's got to be in that order. Part B. Explain the meaning of the ratio that you saw for part A. Right? So what does that ratio up there mean? Does it mean there is 1 dried out Sharpie to every 4 Sharpies that are fine? No, we're looking at 1 to 3. That's their answer. There are 18 dried out Sharpies for every 6 Sharpies that are fine? No, we know there's only 6 dried out Sharpies. There are 16 dried out Sharpies. Come on. You gotta be kidding me, right? There's not 16, there's only 6 dried out Sharpies. There's 1 dried out Sharpie for every 3 Sharpies that are fine. That is exactly what we found out, right? There is 1 dried out Sharpie for every 3 that are fine. So those are the table here shows the running time for Mrs. Edwards. And she can run 5 miles an hour. That's not too bad. Out there getting it in, Miss Edwards. Okay, based on the graph above, how far does Mrs. Edwards run in an hour? Right? We're trying to find her unit rate. And I've already alluded to that, but we're looking for miles per hour, right? So we would need to find what 1 hour is and figure out how many miles that would be, and that would be 5. So her unit rate would be 5 miles per hour. Now it does show us a couple more rates, right? 10 miles in 2 hours, 15 in 3, but we're concerned with the unit rate here, 5 miles per hour. So how far does Miss Edwards run in an hour? 5 miles. Number 7. The box contains apples and bananas, clearly. How many more apples and bananas do you need to add to this box in order to have a ratio of apples to total fruit be 6 to 13? So we need to have, for our ratio to be 6 to 13, this needs to be apples total fruit. All right, that's what we need this to be up here. So we need to have how many apples? We need 6 apples. We only have 3 apples. All right, so let's go ahead and take care of that first. How many apples am I going to need to add to this to make sure I have 6 apples? I'm going to have to add 3 apples, right? So I'm just going to draw circles for apples. A little leaf on top of them there, right? So there's 3 apples that I added, so I can have the 6 apples that I need for my ratio, right? So it's 1, 2, 3, 4, 5, 6 apples. Now is my ratio correct? Well, let's see. I have the 6 apples. Do I have a total of 13 pieces of fruit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No. I need more bananas, right? I need more bananas so I can get a total amount of fruit to be 13. I have 11 total pieces. I need 13, so I need 2 more pieces of fruit. I can't add apples because then that would make this number different. So I can only add bananas. I'm going to add 2 more bananas. So now what I have is a ratio of 6 to 13. 6 apples to 13 total pieces of fruit here. So in order to do that, I had to add 3 apples and 2 bananas. So of the answers down here, I would need to add 3 apples and 2 bananas. Number 8. Last week I spent $150 on groceries, and this week I spent $75. In simplest form, what is the ratio of money I spent last week to the money I spent for both weeks? Well, I spent $150 last week. In both weeks, I would have to add those together, which would be 225. And then I need to simplify this. Now, this one's kind of a tough one, but you can start just whittling it down. Right? I've told my students that if the number ends in 0 or 5, you can divide it by 5. In this case, you can divide these by 25. They're like quarters, right? So this one divided by 25 would be 6, and 225 would be 9. This is still not in simplest form. Obviously, I still don't see my answer over here, so it probably means, since these numbers are smaller, that I need to simplify this even more. So I'm going to go ahead and do that and divide this by 3. This is the greatest common factor. I find out that I get 2/3. So the ratio in simplest form here, money I spent last week to money I spent for both weeks, is going to be 2/3. Number 9. The sign of the grocery store reads, kiwis are 2 pounds for $2.98. What's the unit rate? That's 298 over 2. We want to find out what it is for 1. So all we do here is divide by 2 to get the pounds down to 1. Go up top, divide that sucker by 2 to figure out what it would be for the unit rate. I'm going to do this on a calculator. You guys should be doing it, long division, but I'm trying to make this video shorter. 298 divided by 2. $1.49. Which makes sense because 3 divided by 2 is 150, so it should be close to that. So we're looking for $1.49 per pound. Next. Number 10, part B. If you want to buy 3 pounds of kiwis at the same rate as part A, how much would 3 pounds cost? Well, we know it's $1.49 per pound. So if we need 3 pounds, then we'll again just create an equivalent ratio here. We multiply the bottom by 3, so we have to do the same to the top. And $1.49 times 3, again, do this a little bit quicker, would be $4.47 for all 3. Number 11, the ratio of dogs to cats owned by students in Miss Edwards' class is 5 to 6. Which 2 statements are true? Your job on this type of problem is to find out which of these ratios are equivalent to 5/6, right? So if these ratios simplify to 5/6 in this case, then we would obviously pick those answers. So 10 dogs and 15 cats. So 10 over 15. Let's simplify this down. We'll divide it by 5. And this simplifies to 2/3. That is not equivalent to 5/6, so this is not a correct answer. 25 dogs to 30 cats. 25 over 30. If I simplify this down, divide this by 5 and this by 5, I get 5/6. This is equivalent to that. So this one is a correct answer. Now this one's a little bit tricky because it's comparing cats to total animals. That doesn't mean the ratio, that doesn't mean this isn't a true statement. In this case, we would have to change our ratio here. Cats is 6, total animals would be 11, so that would be 6 over 11. So we're going to take 12 over 22 and see if it simplifies to that. Divide by 2, we get 6 over 11, which shows that in fact is a true statement, right? The ratio of cats to total animals is 6 to 11 in this case. And so this statement is true. So those are your 2 answers for that one. Definitely a tricky one. It's a good one. We've got a couple more questions left here. Number 12, fill in the function table of ounces to pounds. Select 2 statements that are true. Is B equal to 80 ounces? Well, the first thing I would do on this type of problem is figure out how many ounces are in a pound. So if there are 32 ounces in 2 pounds, that's a rate that they give me, then that would give me the opportunity to figure out how many are in 1 if I just divide by 2, right? 2 divided by 2 gives me 1, 32 divided by 2 gives me 16. So there's 16 ounces in a pound. So if there's 16 ounces in 1 pound, how many would be in 5 pounds? Well, I would just multiply by 5 to get there, right? And 16 times 5, 70, right? So 70 would go here. Or is that? Oh, no, sorry, that's 80. And then we have 112, 16. Hold on a second. No, that's right. 70. Sorry. Excuse me. I've been making videos all day. And then 112 ounces over here would be C would give us a total of 112 divided by 16, which would be 7. Okay. So select two statements that are true. Is B 80 ounces? No. B is not 80. Is it? Times 5 is 80. I'm tripping, team. Okay, 80. I'm sorry. 80 is B. 16 times 5 is 80. So B is correct. C is definitely not 12 pounds, right? That's only 7. A is 16. We do know that's true, right? 16 ounces per pound. And obviously, since we know B is 80, it is not 60. So those are your two answers on that one. You and Miss Edwards were fiddling with this problem a bunch. I confused myself there. Number 13. If there are 16 ounces in 1 pound, then how much would 120 ounces be in pounds? Then we're obviously going to set this up as 16 to 1 is equal to 120 over something. We try to figure this out. So in order to figure this out, we're going to do 16 times something will give us 120. We do the same thing at the bottom. Unfortunately, I apparently don't know my 16s facts. So I'm going to have to do some kind of like method here to figure out what do I multiply 16 by to get 120. This is just going to be going backwards. We're going to divide to figure out what that missing factor is. So we do 120 divided by 16. It should tell us what we're missing here. So 16 goes into 120. We know from up here it's 7 times, which is 112, which gives us 8 left over, which is 7 8/16, which is a half. 8 is half of 16, so this is 7.5. So of our answers over here, 7.5 pounds is our answer. Number 14, using the table to answer the question below, if you worked 23 hours, you need $400 to go to a concert, will you have enough money to go to the concert at your current rate of pay? So basically, it gives us our earnings per hour. So we're making $15 per hour, right? So if we work 23 hours, then we just multiply 15 times 23, figure out how much money we would make in 23 hours, and if we could afford a $400 ticket to go to a concert, which is about right for concert tickets these days. So I'm going to multiply 15, or we have 15 for 1 hour. We're going to figure out how much money it would be for 23 hours. So we multiply by 23. And the same thing up top times 23. 15 times 23. Do my multiplication. 4. 1, 2, 3. Looks like if we worked 23 hours, we would make $345. So, do we have enough money to go to this concert? The ticket costs $400. We only have $345. So no, we don't have enough money to go to this concert. We're short a little bit. So these answers that are yes are automatically wrong. So let's pick out which one of these is correct. No, you will not have enough money to do a concert. 23 hours only makes you $391. Well, that's not true. We got $345. No, you will not have enough money to do a concert. 23 hours only makes $345. This is going to be our correct answer for number 14. No, I'm not only going to do $345. Number 15, each day, 7 out of 20 students get school breakfast in the morning. Predict how many students out of 360 would get breakfast in the morning. Again, just your basic equivalent ratio problem where we have a missing number. Total students, the students get breakfast. I'm going to use with the B up top. and total students, TS on the bottom. So kids that get breakfast up here, total students on the bottom. We know 360 students in the school, so that's going to go on the bottom. That's total students. I'm trying to figure out how many of them would pick breakfast, right? So we got to find a way to get from 20 up to 360. And then we'll do the same thing at the top to figure out how many of those students at 360 would. And it turns out that 22 times, no, let's just divide this out. 20 goes into 360, or 20 goes into 36 one time, which is 20. And 20 goes into 65, 6, 7, 8 times, which is 18. So we're going to multiply 20 times 18 to 360 here. We're going to do the same thing to the top number to figure out how many students would choose breakfast of 360. So quickly off to the side, 18 times 7, 8 times 7 is 56, and 7 plus 5 is 12. So it looks like 126 students we could expect to get breakfast out of 360. Hopefully this helps answer any questions you guys got. As always, you can contact me or Miss Edwards. We love hearing from you guys. Keep up the good work. Good luck on your test tomorrow. Peace out.